Hello and welcome to my presentation. My name is Samila Mohammed Harun, and today I'll be talking about spherical mirrors. So let's begin. So what is a spherical mirror? Spherical mirrors are mirrors whose surfaces form a part of a hollow sphere. The spheres can be made out of glass or any other polished metal surfaces. There are two types of spherical mirrors. The first one is convex mirror and the second one is concave mirror. Convex mirror. If the mirror coating is in the inside of the spherical mirror, then the mirror is called a convex mirror. You'll see the diagram in the next slides. Uh, a concave mirror is a mirror that whose reflecting side is on the outside of the spherical mirror. Now, these are the diagrams of the two mirrors. The first type of mirror is the concave mirror. The reflecting surface is the inside of the sphere, which we can see by this diagram. And for the convex mirror, the reflecting surface of the sphere is the outside of it. Now, there are a few terms you have to get familiar with for spherical mirrors. The first one is the center of curvature. It's the center of the whole sphere if the mirror was a sphere. Next is the principal axis. It goes through the middle of the mirror, and it is the normal of the mirror. Also, there is a point here. It's called the F, or the focal point. It is between the center of curvature and the mirror itself. It is halfway between the center and the mirror itself. The focal length of the mirror. When parallel rays of light fall on either a concave or a convex mirror, they're reflected back to a point on the principal axis, which is the focal point. The focus is where the image is formed of an object placed at a far distance. So, for example, if an object is placed at infinity, the image of the object will be formed exactly at the focal point. Now let's talk about real and virtual images. In a concave mirror, the focus is real, and the object and the image lie on the same side of the mirror surface. It is called a real image because it can be caught on a screen itself and not behind the mirror. In a convex mirror, on the other hand, the object and the image lie on the opposite sides of the mirror, of the mirrored surface. The image, therefore, is a virtual image and cannot be captured on a screen. So it can be seen as it is behind the mirror. Now let's get to the ray diagrams of the mirrors. The first one is the concave mirror. In a concave mirror, we have six cases or six situations. The first situation is when the object is placed at an infinite distance from the mirror. The image will be formed at F, and the image will be inverted. Uh, the second situation is when the object is beyond the center of curvature, so it is far away. It is far away, but not at infinite. The image is formed between the center of curvature and the focal point, as we can see in this diagram here. It is inverted as well. The third case is when the object is located at the center of the curvature exactly, and the image itself will also be located at the center of curvature, but it will be inverted. The next case is when the object is located between center of curvature and the focal point. The image will be formed beyond the center of curvature, and it will be inverted again. The next situation is when the object is at the focus or the focal point. The image formed, or actually there will be no image formed, or we can say the image will be at an infinite distance from the mirror. The last situation is when the object is located between the mirror itself and the focal point. The image here will be virtual, it will be upright, and it will be enlarged. Next, we have the ray diagrams of convex mirror. Here it doesn't matter where the object is located. The image will always form behind the mirror, and it will be located between F and the mirror itself. The characteristics of the image here will be that the image will always be smaller than the object. It will be virtual, and it will be upright. We use two ways here to find out where the image will be formed. The first one is perpendicular to the principal axis, and then once it hits the mirror, it goes through the focus behind the mirror, and the second ray goes straight through the center of curvature behind the mirror. And the intersection between these two rays is where the image is formed. And in this case, for the convex mirror, it will always be between F and the mirror itself. Thank you for listening, and that is it for me.